You're going to need your calculator. So this is the problem that brings us right into the front part of calculus. There's really two main topics in calculus. That's differential calculus and integral calculus. You will get a full debriefing of both types. We start first semester really with the examination of what we refer to as differential calculus. And this is the problem. It says the tangent problem. Given a curve with a line tangent at a given point on the curve, so for example, let's say I draw a curve. Well, I'm drawing the curve x squared plus 1. Okay. Let's say that we have a point on it right there. It says given a curve with a line tangent do you agree that's an okay drawing of a tangent line? You can draw it if you want. Question is, what is the slope of the tangent line? Can somebody identify for me why it would be difficult to identify the slope of that tangent line? You only have one point. Slope m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 requires 2 points. We only have one. Now, I'm not talking about an estimation. I'm talking about exact. We want to know the exact value. And I can look at this right now, and I will teach you. There will come a point where I can look at the equation, and I can look at the point, and I can tell you that the slope of the tangent line is 2. Now, I'm going to teach you how to do that. That would serve you no good purpose. So, if we have this function, f of x is equal to x squared plus 1, I want to find an equation for the line tangent at the point 1, 2. So we're going to call this point here 1, 2. Okay? Now, here's what I'm going to do. In order to find an equation for a line tangent, I need two things. I need slope, and I need a point on my line. Everybody agree? I need those two things. Well, I don't know how the calculus works yet, so I'm going to come up with an approximation to start with. And what I'm going to do is I'm going to select point P, which is 1, 2, and I'm going to select another point Q that has an x value of 2. Okay, we'll put it, say, right here. Okay. Can somebody tell me what is the y value of Q? 5. How do you get 5? Yep. 2 squared is 4 plus 1 is 5. So the location of this point is 2, 5. Would you agree that the slope of the blue line is an approximation of the slope of the black line? Is it a good approximation? Not really. It doesn't really look like it, but we could get an approximation. So if we use the points 1, 2, and 2, 5, what would the slope be? Right, so 5 minus 2 over 2 minus 1, so 3 over 1. So the slope was 3. What would you do? Super important. Everybody watch this. What would you do if you wanted a better approximation? Slide it closer. So important that you see this idea. It'll come back around the next 3-4 days. We're going to take this and we're going to slide it closer, okay? We're going to move it closer. In fact, we'll move it to 1.5. If I'm sitting at 1.5, would you agree that the blue line now represents a better approximation of the slope of the black line? Okay, these blue lines are called secant lines. The slope of the secant line is approaching the slope of the tangent line, right? We're trying to get closer. So what is the y value of this coordinate 1.5? 3.25? Okay, now let's find the slope of that one. I have 3.25 minus 2 over 0.5. What do you get? 2.5. So our first value is 3. Now we got 2.5. Do you remember what I told you was the slope? It is 2. And we're going to see it kind of come down here. Now I'm going to move to 1.1. Oh boy. So I'm going to move even closer in here. Okay? I just know I just told you. That's the only way you know. You have to trust. Trust me. Okay. So we're going to put a point right there, really close, right to it. Can't even really see the difference. It has an x value of 1.1. What is the y value? 2.21. Okay, so 2.21. I can now calculate the slope. 2.21 minus 2 over 1.1 minus 1. And what do you get? 2.1? Should we even draw any more pictures? No. Do you see what's happening to the values? The x values are getting what? Very close to each other, aren't they? 1.1 and 1, 1 and 1.01, 1 and 1.001. Can you calculate the slopes of these last two? Has anybody done these? What do I got? 2.01. If you do this one, you get is this enough data to convince you that it's approaching 2? Yeah. Have we proven it's 2? No. What we've done is we've gathered a lot of data. We've pushed it very, very close. Now, I want you guys to get an idea here on something. If we were going to find the exact value, how close would we have to push these points together? Right on top. Infinitely small, right? If they were 1/10 of a unit away, is that close enough? If they were 1/100th, 1 over infinity. Infinitely small. I'm going to show you tomorrow how to deal with something that is infinitely small. So we're able to answer this question, though, by simply stating m is equal to 2. The point on the line is equal to 1, 2. I can now write an equation for the slope of that tangent line. It's a best guess. We believe that the slope is 2. We have not yet proven it. And so I take my point, y equals mx plus b. I have a y value of 2. I have a slope of 2, x value of 1. So 2 equals 2 plus b. 0 is equal to b. So the equation for the line is simply, that is the equation for the line tangent. So I told you last year that we would investigate this problem, how to find slope at just one point. Now again, we haven't actually done it. We've gathered information. I'm going to show you how to confirm it, how to get an exact value from it. You have no assignment tonight. Your jobs are to sign up, except for Solveig, for the senior dinner and dance. Okay, $20, District 241. Make sure you finish up your mathematical induction. Tomorrow we will build off of this. And your first assignment you'll like. You'll roll through with it. This first unit you'll like. And we'll get to more difficult stuff after that. Oh, books. Okay, books tomorrow, because you don't need them tonight. So books tomorrow, right at the beginning of class, let me know. No, your assignment is to again, you're supposed to choose 3 problems. Finish those 3 mathematical induction problems. If you're having trouble, your first test will have a math induction problem on it, I promise. At least one. So if you don't know how to do it yet, you got to come see me. I know a lot of you figured it out, but if you haven't, you got to come see me.